Welcome to the continuation of rates and speed and unit rates and real-world problems involving distance, time, speed. So, if you have not watched the video before this, where we talked about distance and speed and how we calculate those, I would strongly recommend going back and finding this video. If not, or if you already have, then great, let's jump on into it. So, real fast recap, we looked at the relationship between distance, time, and speed. We used this triangle to help us remember the formulas for calculating distance, or calculating speed, or calculating time, if you know those two other values. So, as we look at this next round of problems, we are going to be utilizing this information a lot, and I'm not going to be going into the why do these formulas work in this video. That was last one. So, if you get lost, go back, check that out. Otherwise, we are going to be moving forward with 5 types of problems that involve distance, speed, and time. So we came up with these names in class, and I forgot to add the purple names on here. Apologies. But this helps us identify what's happening in here and how the type of problem affects the calculation that you have to do. And so leading up to this, especially in math prior to it, a lot of the problems, you've been given a problem like this one from our last video, where Melanie ran a distance in a particular amount of time, and to calculate her speed, you just need to use those two pieces, those two numbers, and do some sort of calculation. And that's how you got your answer. You could look at it, and we know you could either multiply or you could divide. That would get your speed. End of story. The problems that we're going to be looking at today are not quite as straightforward. These would be considered multi-step problems, or problems where you have to look at what do you know from the problem, what question are you trying to answer, and then how can you get from what you know to what you need to know. Because it's not always just going to be take the numbers given in the problem and multiply or divide them. You're going to have to do some other work in between there. So as we go through, we are going to be looking at these different problem types. I feel like this one in purple we called there and back. This one was come at me, bro. This one was, I want to say, go away. Go away. Oops. Go away, brah. Multi-step. This one, I can't remember what we called that one. And this one was wanna race. So those are obviously not like the official math terms for that, but it does help you identify like, ooh, a circle of life, you're going around, or you're doing a round trip, you're going from one point to the other and then back again. So just kind of a fun way to connect those back here. I just wish I could remember what we called that multi-stop one, but regardless, we will be identifying these types of problems as we go through to see how they're different. So I guess let's start here. Circle of life problem will sound like somebody starts at one point, goes to another, and then comes back again. So you travel from point X to point Y, and then back from point Y to point X. Rendezvous, you have people starting at opposite ends and traveling towards each other. The hot dog mirror, it's not you, it's me, and the go away bra. You're starting at the same point in the middle and then traveling in opposite directions. The multi-stop, or the gas is overpriced, is you're going from one point to another, then to another one, continuing on. And then the Mario Kart, you are starting at the same point, going towards a similar destination. One person arrives there first, the other one doesn't quite make it there, and then you have questions about distance, time, or speed based on that scenario. So as we read the problems, we're going to try to identify which type it is and then how we're going to solve that. So if we look at this first one here, Lila took 10 minutes to run from point A to B at an average speed of 180 meters per minute. She then ran from point B to point A in 15 minutes. Find the average speed in which Lila ran from point B to point A. So up here, this one to me sounds like a circle of life, because instead of it being X or Y, it was A and B. She ran from A to B, and then B to A, and we need to find something out about one of those legs or both of those legs. So let's do a quick picture that looks like that, and then see what do we know. So we know Lila started at point A, she ran to point B. Her speed going in this direction was 180 meters per minute. And then she ran back with a time of 15 minutes. Oh my gosh, and I missed this first piece here. Her time here was 10 minutes. Then our question, find the average speed in which Lila ran from point B to point A. So we want to find this piece of information there. So I know from my triangle that distance, time, and speed, if I'm looking to calculate speed, I need to know the distance divided by the time. And if we look here, I don't know the distance from B to A so that I can calculate that. So this is where the problem solving begins. And we need to look and see, what information do I have that will help get me to know that distance? And because this is a round trip, I know that the distance from A to B is the same as the distance from B to A. So if I know in this top part here, the time and the speed, going back to my triangle, I can calculate that distance because distance is speed times time. So if I find this value from A to B, that's going to give me my missing piece for B to A, and then I can get on to answering this question. So our distance is 180 meters per minute times 10 minutes. So that's going to be 180 with an extra zero on there, or 1,800 meters. So if that's how far it is from A to B, that's also going to be the distance from B to A. So now I know my time, I know my distance, and because of that, I know these two pieces of information, I can calculate my speed. Speed equals distance divided by time. 15 minutes, I think, yeah. So again, I'm not a super huge fan of long division, so I'm going to use some branching because this lends itself to a lot of these problems, where I know I'm going to pick numbers based on this 15, where 1,800 is 1,500, and then a 300. And these are good numbers to pick because 1,500 divided by 15 is 100, and 300 divided by 15 is 20. Because if this was 30 divided by 15, that's 2. But it's got to be 10 times greater. So 10 times 2 is 20. So we know Lila's speed from B to A is 120 meters per minute. So real quick up here on this problem, I'm going to jot down things that we learned for this one. We know that the distance from X to Y equals the distance from Y to X. And that's a really helpful piece because that allows us to calculate some missing information. So I am going to try to keep track of what are the useful bits here, so that way we can know if we encounter these problem types, what do we do? So let's move forward. And I am going to take a quick reasonability check because I do think that's important to think about this. From A to B, she traveled at 180 meters per minute, and it took her 10 minutes. B to A, they tell us it took her longer to return. So she's traveling the same distance in more time. So that must mean logically that she's traveling slower. So if I look at my answer here, 120 meters per minute compared to 180 meters per minute, she is traveling slower from B to A based on that speed that we calculated. So my answer does seem reasonable, and we are good to go. Okay, moving forward. Elena drove from city A to city B. She took 2 hours to complete 1/4 of the journey. She drove the remaining 252 kilometers in 3 hours. Find Elena's average speed for the whole journey. So I'm going to do my visual, my model, diagram. So we're going from A to B. And this one is kind of like a fraction piece because they give us some information. I would consider this almost like, let's see, a multi-stop, because we have multiple parts that we're doing calculations on, and they're giving us information about those parts here. Sometimes it will tell you the 3 points, but in this problem, it's giving it to us as a fraction. She took 2 hours to complete 1/4 of the journey. So if we take this journey and we split it into 4 pieces, we know in this piece, that time was 2 hours. Then, for these remaining pieces, that time is 3 hours, and she drove those remaining kilometers, which is our distance, 252 kilometers. So if we want to find our average, let me try that again. If we want to find our average speed for the entire trip, we need to know our total distance, we don't have, and our total time, and total time. So again, our triangle of fun, the Illuminati, speed, is distance divided by time. So we need to figure out those missing values. Let's dig into what we know and what we can figure out. Now, the first thing that really stands out to me is this first chunk is 2 hours. That last chunk is 3 hours. So that must mean it took her a total of 5 hours. Great. Now we need to calculate the total distance. Now, we know the distance from this second part, but we don't know the distance from this first part here, this first leg of the journey. And they only give us time there. They don't give us speed. So we can't we don't have enough information just from that, looking at that little section to figure it out. Fortunately, though, if we look at this picture, we can see that this distance of 252 kilometers is 1 segment, 2 segments, 3 segments. And so if I know that those 3 segments equal 252 kilometers, if I find out the value of one of those segments, I can add that on and calculate the whole distance there. So 3 segments is that. 1 segment is going to be 252 divided by 3. So again, I am going to use branching because I know my multiples of 3 really well, and 3 and 24 are related. So if it's related to 24, it's related to 240. And then that leaves us with 12, which is also great to divide by 3. So 24 divided by 3 is 8, and these are 10s, 240, 24 tens, so 80. So we know that each one of those portions, each one of those segments is 84 kilometers. So if that's 84, that's 84, that's 84, then that must mean that this one is 84 as well. So our total distance down here is going to be those 252 kilometers that they told us in the problem here, plus the 84 kilometers from that beginning. So 252 plus 84 is going to be 336 kilometers. Okay, great. So now to calculate speed, we've found our distance, we've found our time, we just need to do some division. So our speed is going to equal 336 divided by 5. 5 hours to travel those many kilometers. Well, let's do some branching. You know what? Actually, I'm going to do long division on this one. I haven't done that much. Equal opportunity strategy user. 336 divided by 5. 5 goes into 3 0 times. 5 goes into 33 6 times. So 5 times 6 is 30. Roll up to 3, 6. 5 goes into 36 7 times, and that's 35 and 1. So we have 67 and 1/5 because we have one of the 5 that we need to make another group. So Elena's speed is 67 and 1/5 kilometers per hour. And if you wanted to, you could think of that like it was 2/10 or 67.2 kilometers per hour. So, let's look and see. This problem has a lot of calculations there, but the calculations themselves aren't super difficult. What we needed to do, though, was first look at this problem and see, what do we know? And then if we know that information, how can we do some math to figure out those missing pieces that allowed us to calculate our speed at the end? And with these problems, there's always going to be enough information, if you look at it the right way, to kind of fill in the blanks, fill in those missing pieces that allows you to get to that final calculation. So if we go back up here, multi-stop, I feel like average speed, we should probably make a note of that. Average speed is total distance divided by total time. And so doing some sort of work to figure out any of those pieces will allow you to figure out really anything else based on that. If you know that speed and the time, you can calculate the distance. If you know the distance and the speed, you can calculate the time. So you just got to figure out, what do you know? What don't you know? All right. Bus X and Y left a school at 2 p.m. for a stadium. So they're leaving from the same place, starting to clue me into that problem type already. Both buses did not change their speeds throughout the journey, so constant speed, okay? Bus X traveled at a constant speed of 60 kilometers per hour, so I know the speed for one of them. When Bus X arrived at the stadium at 2:30 p.m., Bus Y was 3 kilometers from the stadium. Find the speed of Bus Y. Okay, my initial thoughts are they left from the same place, headed to the same destination. One of them made it, the other one didn't. So one of these buses was traveling faster than the other one. Let's see what we got here. So we know they are starting out here at the school, and it's 2 p.m. And we have Bus X and we have Bus Y, and they are traveling all. Bus X made it all the way, and he got there by 2:30. And we know the speed from this problem was 60 kilometers per hour. Bus Y drove, they didn't quite make it. They were 3 kilometers from that stadium. And that's all we know. And we need to calculate Y. Oops, the speed of Y. So, and remember, according to our triangle of fun, speed equals distance divided by time. So in order for us to calculate this speed, we need to know distance and we need to know time. So let's see what we know from this problem, because nowhere does it tell us they took this many minutes to drive or this many hours to drive. However, they did tell us you leave at 2 p.m., you get there at 2:30. We do know our time, even though it doesn't explicitly state it. Our time is 30 minutes. Now, I'm not going to leave it in this unit because those 30 minutes compared to those hours, they don't match up. In our previous video, we talked about how when doing these calculations, you need to have constant units. You need to have these units be the same. You can't measure your speed in kilometers per hour and then just multiply it by 30 or divide by 30 because those are minutes, not hours. But fortunately, I know 30 minutes is half an hour. So this here says when Bus X arrived at that stadium. So that is a sneaky way of saying after 0.5 hours. Bus Y was 3 kilometers. So we know that this is for the same amount of time, those 5 hours. So we've identified our time for both Bus X and both Bus Y. We need to figure out that distance that Bus Y traveled. But in order for us to calculate distance using the triangle, we need distance equals speed times time. We only know time, we don't know speed. So we can't use the formula to calculate the distance for Y. But I do know, if I notice up here, I know now 2 pieces, time and speed, for Bus X. And so that could tell me that whole distance. Now, if I know the whole distance, and I know that Bus Y drove all that distance except 3 kilometers, once I find out the full distance from the school to the stadium, I can take away those 3 kilometers, and that will tell me Bus Y's distance. So let's calculate Bus X's distance. So distance equals speed times time. 60 kilometers times half of an hour. Half of 60 is 30. So they traveled 30 kilometers. So that school to the stadium has a total distance of 30 kilometers. So if we know that full distance is 30 kilometers, that means that Bus Y drove, if they would have gone all the way to the stadium, they would have driven 30 kilometers, but they didn't. They only made it 3. They were there except for 3. So 30 minus 3 is 27. So Bus Y, they only drove 27 kilometers. Ooh, check it out. We now know distance and time for Bus Y. So our speed for Bus Y is our distance, 27, divided by 1/2. Now, divided by 1/2 is the same as multiplying by the reciprocal, which is times 2. So the speed of bus Y was 54 kilometers per hour. Now, before I finalize this, I do want to quick check and see, is this reasonable? Bus X made it the whole distance in the same amount of time. So that tells me bus X had to be traveling faster because they, in the same amount of time, traveled more distance. So they traveled 60 kilometers per hour on bus X, bus Y traveled 54. So it does seem to make sense that because bus Y didn't drive as far, they had to be going slower. And so, yeah, check it out. We did get at least a reasonable answer. Okay, lots of thinking for one problem. And if we look at this, the information we needed to solve, which we first had to identify what was the time for both of them. And then in order to calculate the distance that bus Y traveled, we had to calculate the distance that bus X traveled. And we were able to do that because we knew 2 of those pieces of information for our formula. We knew speed and time for bus X, so that allowed us to calculate the distance for bus X, which then allowed us to calculate the distance for bus Y. So these problems, they give you what you need to solve them, but you have to do some thinking to see, if this is what I know, what can I at least find out? And so I think that's one of the biggest things with these problems, is being able to stop and say, all right, you know what? I drew this picture. This is the information I have. I don't quite know what I need to do, but if I'm given this information, what calculation can I do to at least get started and move me towards a direction? If I identify the thing that I'm trying to find and the information that I need to find it, how do I get from what I know to the information that I need to find it so I can find it? All right, so let's quick scroll back up here to our problem types. This one seems like a Mario Kart, a Wii, or a Wanna race, because those ones start at the same point. Their goal destination is the end. And so, let's see, on this one, usually this piece right here is the crucial piece. And so, knowing the distance, the whole distance, the entire distance, the total distance, I like total distance, the total distance minus the remaining portion tells the distance of the slower vehicle, basically, of the slower thing, because it could be a vehicle, it could be a person, it could be a different whatever. But if you're able to find out the total distance, here's our total, and then this is the remaining. Here is the other distance. And so that relationship is often what helps you unlock these problems. All right, we have, 2 more problem types left. Hopefully there's 2 more problems in this slideshow. So 2 classmates, Anthony and Hayden, started walking from their school in opposite directions. Oh, that's a dead giveaway. So before I even go any further, we know they're going to start here. One is traveling, because it said they're going in opposite directions, leaving from the school. We know this one's Anthony, that one's Hayden. Okay, now I'm going to continue. I got that out of the way. Anthony walked at a constant speed of 4 kilometers per hour. Hayden walked at a constant speed of 6 kilometers per hour. How far apart were they at the end of 15 minutes? Okay, so digging into this, we know Anthony's speed was 4 kilometers per hour, and Hayden's speed was 6 kilometers per hour. They're traveling the same time, and so I know that Hayden was traveling faster, so he should go farther. But I'm looking at this time, and I notice our units again, they don't match. These are 6 kilometers per hour, and they tell us the time is 15 minutes. So I need to turn these minutes into hours so I can do my calculations. And I know that there are 60 minutes in 1 hour. So we have 15 of the 60 minutes that we need in order to make 1 full hour. So we don't quite have 1 whole hour. In fact, these are both divisible by 15. We have 1/4 of an hour. So our time is 1/4 hour. So they both traveled 1/4 of an hour. And we want to know the distance, how far apart were they? So we want to know this distance here. So even if I don't know where to begin, I know from my triangle that distance, speed, and time are related, and I know two pieces of information. I know the time, and I know the speed. So because I know these two pieces here, I can calculate that remaining one up there. So my distance is speed times time. So when in doubt, let's just see what we can figure out. And we can find the distance for Anthony and the distance for Hayden. So Anthony's distance his speed of 4 times 1/4, and that is 1. So he travels 1 kilometer. So I'm going to write that one there. And you know what? I'll write it up here because why not? So now we need to look at Hayden, who traveled. So his distance is going to be his speed of 6 times that same 1/4 of an hour. Before I multiply, I'm going to simplify by dividing by 2. And so I will get 3 over 2, or 1 1/2. So he travels 1.5 kilometers. And Anthony travels 1 kilometers. Now, because they're traveling in opposite directions, that means they started here at the school, and when Hayden ends, he's 1.5 kilometers away from where they began in one direction, and Anthony is 1 kilometer in the other direction from the school. So that means altogether, they've traveled 2.5 kilometers. So 1 plus 1.5 is 2.5 kilometers. So how far apart were they? They were 2.5 kilometers apart. And then if you look at those questions at the bottom, how far would they be after 20 and 90 minutes? That's just going to affect your time, which then means the distance is a little bit longer. So we're not going to look at that there, but this does seem pretty reasonable. We organized what we knew, we looked at what we could calculate based on that, and then that allowed us to find our answer for how far apart. So when they're walking in opposite directions, this is the hot dog or the mirror, you got to do some calculations and then do some adding, or look at the relationship between, because this one's usually going to be about distance. Something with distance is going to be in this problem, because the fact that they're traveling further apart means that distance is going to be key. You need to look at that part to part, or part to whole relationship. I ran out of room. Okay. All right, we only have one more, the rendezvous, the come at me bro, the meet with porcus, I think is what we called that one, because pork and meat. Okay, these are those infamous 2 trains leave. When do they intersect? When do they run into each other? So town A and town B are 715 miles apart. A van travels at a constant speed of 75 miles per hour from A to B. At the same time, a truck travels at a constant speed from 55 miles an hour from B to A. How far has that van traveled when they meet? This is looking confusing, but we know we have 2 towns, A and we have B, and their distance apart is 715. So if you drove all the way from A all the way to B, you would travel 715 miles. So we have a truck and a van. The van starts at A and travels this way. The truck starts at B and travels this way. The van travels at a speed of 75 miles per hour. The truck travels at a speed of 55 miles per hour. How far has the van traveled when they meet? Ooh, okay. Doesn't seem like they give us a ton of information here. We have nothing about time. And if we're calculating distance, according to our triangle, or distance, speed, time, distance equals speed times time. We know the speed of the van, so we need to know how long it took for those 2 vehicles to meet. So how are we going to find out that time? Well, I'm going to do some thinking, because I know that in 1 hour, that van travels 75 miles, and that truck travels 55 miles. So in that 1 hour, you could think of it like this. Here's 75. Here's 155, it seems like, not 155, bro, okay, 55. It seems like in that 1 hour, the distance that was traveled in 1 hour is 75 plus 55. 130 miles. Now, let's see. That doesn't mean that the truck was driving 130 miles per hour or the van was driving 130 miles per hour. But together, those two vehicles traveled a total of 130 miles in 1 hour, which means they would travel 260 miles in 2 hours, because each hour the van travels 75 miles, the truck travels 55, so each hour together they get 130 miles closer together. So I know that back from one of our first video, or one of our last videos up here, that speed is a rate of distance per some unit of time. And so this distance traveled in 1 hour, check it out. So we know that the collective speed in this situation is 130 miles traveled in 1 hour. Those vehicles are traveling 130 miles per hour in this scenario. Not in the same direction, but towards each other. We have to add their speeds together because in that 1 hour, that many miles is traveled. A total of 130 miles is traveled. So if we want to figure out when they're going to meet, how many hours it's going to take for them to meet, that means the distance between them will be 0, because that's when they meet. They'll be, let's see, the van is moving faster, so they'll meet here. Let's say somewhere in there. This is where they meet. So by the time they meet, they will have traveled all 715 miles. So we need to figure out, at this speed, how long is it going to take them to travel 715 miles together, collectively? So the collective time that it will take, time equals distance divided by speed. So their collective distance that they will travel is 715 miles, and their collective speed is 130 miles per hour. So we need to do that division, and 130, 100, let's see, if I do a couple little side calculations, 130, 260, 390, 520, I think I'm going to go with this 390. So if I think of this as a 390, that divided by 130 is 3 hours so far. And 715 minus 390, 5 minus 0 is 5. 11 minus 9 is 2. 6. Okay, so 325 is remaining. So I can't do another one of those, but I can do a 260. And, oops. So if I branch that into a 260, that would leave me with 65. So 260 divided by 3 is 2. 65 is half of 130, so that's 0.5. So 3 hours plus 2 hours plus a half of an hour is 5.5 hours. So in 5.5 hours, they will meet. It will take them 5.5 hours to meet. So that means if the van A travels 5.5 hours and the truck travels 5.5 hours, that is the point when they would intersect. Now, that doesn't mean that the truck drove all 715 miles in that time. It just drove its portion in that time while the van was also driving towards it. Because remember, these vehicles are driving together. They're driving at the same time. So as the truck is making progress, the van is making progress. So they drove for the same amount of time, but their distance is going to be different because they're driving at different speeds. And so that's what this question is asking. We now know that that van is going to travel 5.5 hours. The truck is going to travel 5.5 hours. And whatever distance they cover together should add up to 715. But we don't really care about the truck. We just care about the van. So that van's distance is going to be the speed of 75 times his time of 5.5 hours. Well, let's see. How do we want to do this? Let's look at... It's really nothing super fancy that we can do here, I guess. We could do the algorithm. We could do 75 times 5. Ooh, and 75 times 5/10. Ooh, that could be helpful. So 75 times 5 is going to be 350, because that's 7 times 5. 70 times 5, plus 25, so that's 375. And I know that 5/10 is 10 times less, so I could just move that decimal point over 1, so make that 37.5. Add those together, we have a half, we have 2, we have 1, so 412. So that truck drives 412.5 miles. And that, or I'm sorry, that van will drive 412.5 miles when it will reach the truck. Hot dog, that's a lot of work. That is a lot of thinking, a lot of math. But the piece that unlocks that is the idea of collective speed, or the collective distance. So, if we're thinking about what is the piece that unlocks this, is you need to add the speeds, because that is the distance, the total distance traveled in 1 hour. So then once you know that, you could then calculate time, or you could calculate speed. Calculate distance, rather. So that's the piece that unlocks that one. If they're traveling towards each other, you need to think about the amount of ground that is covered in that hour is whatever the speed of one vehicle and the other speed of the other one together. So that is our rate problems, our rate chapters on how we calculate that. And you can see how all of the pieces come together to get us into one of these super complicated problems. But if you take a moment to draw it out and see what can I figure out, what do I know, they can be quite reasonable.